Hey, welcome to the Explainer. So, if you've ever built an AI feature, you've definitely felt this pain, right? You get a prompt working perfectly on your machine. It's just brilliant. And then it completely falls apart in the real world. It's so frustrating. Well, today, we're going to dig into prompt evaluation. This is the engineering discipline that takes you from just guessing and hoping to actually guaranteeing that your AI is reliable when it really counts. All right, so let's just jump right into the big question. Why does this happen? You know the drill. You spend all this time crafting what you think is the perfect prompt. It's humming along beautifully on your dev machine. But the moment real users get their hands on it, it's a total mess. It's unpredictable, so what gives? Well, it all comes down to that huge gap between our neat, tidy testing world and the messy, chaotic real world. You know, the real problem here is how we're approaching it. It's like you've got two paths. On one path, there's what we could call ad hoc guesswork. Yeah, it feels fast, you're just hacking away at it. But the results, they're unpredictable, they're inconsistent, and man, they get expensive fast. Then there's the other path, systematic evaluation. This is a true engineering approach. It's disciplined. And what does it get you? Prompts that are reliable, consistent, and efficient. That's the leap we all need to make. So, here's the bottom line. Without a proper process, you're not just building a cool new feature. Nope. You're actually building a liability. I mean, think about it. You're shipping inconsistent results to your users. You're burning through cash with inefficient API calls. And you're basically flying blind with no real way to know how to make things better. And the risks here are very, very real. You've got prompts that fail silently in the background, which is just a recipe for a terrible user experience. Your users get frustrated, maybe they even leave, and you're stuck. Without objective data, you're just guessing. Is this new prompt better than the old one? Who knows? You're just throwing things at the wall, wasting time and a whole lot of money. So how do we get out of this mess? Well, the concept is actually pretty simple. We need to start treating our prompts like we treat our code, with the same rigor, the same discipline, the same testing mindset. It's time to stop being prompt artists and start being prompt engineers. And that right there brings us to what we call prompt evaluation. Look, the best way to think about it is this. It's basically quality control for your AI. It's the process where you put your prompts through some serious paces, making absolutely sure they hit a high bar for accuracy, consistency, and reliability before a real human being ever interacts with them. Okay, so this whole thing might sound kind of complex, but it actually boils down to a really clear, really actionable framework. It's built on three main pillars, and when you put them all together, they give you a complete 360-degree view of how well your prompt is actually performing. And here they are. Think of these as three different lenses you look through to evaluate any prompt. First, we've got the hard numbers, the quantitative metrics. Second, we have the human element, the qualitative assessment. And third, we've got the resilience check, structured testing. Let's break each of these down. All right, pillar one, quantitative metrics. This is all about measuring the stuff you can count. Simple questions, right? Is the output correct? That's your accuracy rate. If you run the same prompt 5 times, do you get roughly the same answer? That's your consistency score. And of course, the big ones, how much does it cost in tokens and how fast is it? Because let's be real, a super accurate prompt that's slow and expensive might actually be useless. These numbers, they don't lie, they give you the objective truth. But here's the thing, the numbers only tell you half the story. You could have a prompt that's 100% accurate, but the output is still just awful. Maybe it's written in this robotic, confusing way. Or maybe it technically answers the question, but totally misses what the user really wanted. This is where pillar 2, the qualitative part, comes in. It's where a human has to look at it and answer one simple but crucial question. Is this actually good and useful? Okay, so now you've got a prompt that's efficient on the numbers side and it looks good on the quality side. Awesome. But can it take a punch? Is it resilient? That's where pillar 3, structured testing, comes into play. This is straight out of the software QA playbook. We build a safety net, we hammer it with weird edge cases, we run A/B tests to see what really works, and we literally push it until it breaks. Why? So we find its limits, not our users. All right, enough with the theory. Theory is great, but let's see this thing in action. We're going to take a super simple, super common prompt and put it through this exact framework. And you're going to see just how massive the difference can be. It's pretty incredible. And here it is, the classic summarize this article. I mean, we've all written a prompt almost exactly like this, right? Seems simple enough. But when you actually measure its performance, oh boy, the results are not what you'd hope for. So, running this through our initial tests was, well, it was a bit of a disaster. We're talking a 40% accuracy rate. Just let that sink in. It was wrong more often than it was right. And consistency? Only 50%. That's literally a coin flip for whether you get something useful. You just can't ship a product like that. No way. So, what do? The temptation is to just start fiddling with the words, right? Guess and check. But no, we're going to use our framework. We're going to start by defining very clearly what a good summary even means. We're going to engineer a solution, not just stumble into one. Instead of that vague one-liner, we defined our requirements. We decided a good summary had to be exactly 3 sentences, in a numbered list, using clear language, and it had to cover the main topic, the findings, and the implications. These aren't just suggestions, they are hard requirements that we can actually test for. And would you look at those results? They really do speak for themselves. Accuracy just skyrockets to 95%. Consistency jumps up to 90%. And look, we didn't just get lucky here. This was an engineered result. We got exactly what we asked for because we built a prompt that was clear and testable. It's not magic, it's just good engineering. And the best part? It's a repeatable process that gives you predictable outcomes every single time. So this process isn't just some abstract idea, right? It's a practical blueprint. So let's boil this all down. What are the key takeaways you can start using in your own work, like right now? Let's lay out your quality blueprint. Okay, here's your playbook. First, and this is non-negotiable, test for consistency first. I don't care if a prompt is brilliant sometimes. If it's unreliable, it's useless. Aim for at least 80% consistency before you even touch anything else. Second, set up quality gates to find your minimum scores for accuracy, quality, whatever matters to you. And if a prompt doesn't pass, it does not go to production, period. And finally, let the data do the talking. A/B test your prompt variations against each other on the same set of tests and find the objective winner. No more guesswork. And that brings me to my last point, and it's a really important one. Why do all this? Why move past good enough testing? Because it's not just about hitting some numbers on a dashboard. It's about earning and keeping your users' trust. Every single time your AI gives a weird or wrong answer, that trust chips away a little bit. Systematic evaluation isn't just a process. It's how you build AI experiences that are professional, reliable, and ultimately trustworthy.